right. Thanks, Daniel, for that lovely introduction. And hi, everyone. I'm here today to talk to you about server-side rendering web components everywhere with WebAssembly. Quick little bit about myself before we get started. I'm MacDonald, the head of developer experience at Begin. We're a company that makes dealing with AWS a lot easier. So it's really a fun job. If you need to get in touch with me after the conference, the best way to do it is at my Mastodon account, which you can see right there, because I'm basically no longer checking my messages on the bad website, and you shouldn't either. It's much better for your health, trust me. Also, I'm here in Ottawa, Ontario, Canada, and we're experiencing some thunderstorms right now. So if I get knocked offline, I promise you I will record this talk and post it up so that everybody can see it. So just some feedback there, just in case I just disappear. Sorry in advance. Yeah, see, I proved I'm Canadian. I've already said sorry. We're not even a minute into the talk. Anyway, developers love building components. The allure of reusable pieces of UI with encapsulated state and behavior is really hard to resist. So the popularity of JavaScript frameworks like Angular, Preact, React, Svelte, and Vue validate that there's a need for this type of functionality. But what we're going to talk about today are web components. And web components is a suite of different technologies that allows you to build reusable custom elements with their functionality encapsulated away from the rest of your code and utilize them in your web applications. So web components are not really one thing, they're more of a suite of things. And one of the sets of APIs that we're going to talk about is custom elements. So it's a set of APIs that allow you to define custom elements and their behavior, which then can be used as desired within your user interface. So that's that little piece of code that allows you to say that my header is this reusable piece of code that I'm going to use all over the place in my website. Another one of the specifications is the shadow DOM. Again, a set of APIs that allow you to attach an encapsulated shadow DOM tree to an element. So it's rendered separately from the main document DOM, or what people are now referring to as the light DOM. And so you can control the associated functionality. In this way, you can keep the element's features private so that they can be scripted and styled without any fear of collision with other parts of your document. So the shadow DOM is really good for encapsulating a lot of your styling so that any styling you do inside of the shadow DOM does not leak out into the light DOM. So you can have a button style inside of your web component that doesn't leak out to all the other buttons that are on your web page. And then the third specification is HTML templates. And that's really where we have the template and slot elements that enable you to write markup templates that are not displayed on the rendered page. So the template element is pretty unique in the fact that you can have it in your web page, but it's never displayed anywhere. It's inert. And so what you use is the template to create web components using JavaScript. And so that allows you to reuse that template multiple times on the page. So say you had 10 different buttons, you only need the template once, you create your 10 buttons, it helps you with reuse. And then the slot element, which is part of the specification as well, allows you to compose larger, more complicated components out of their smaller components. So it's a really great way of doing composition to build out components. Now, web components are browser native technology. And all of the specifications that I just talked about are available in all of those evergreen browsers. So evergreen browsers are basically your major browsers, and they are always updating for you, so you're never out of date. I feel bad for some people that I know here that work in the government of Canada that haven't had their systems upgraded since 2007. Hope you folks are not running into those same issues. But the benefits of using platform native APIs include a number of things. First and foremost, you reduce the application bloat. So by design, frameworks bring in additional code to the project, and that's going to increase the app download size for your users. Now, web APIs, however, are already there. They're part of the browser. They're written in C or Rust. So they're already there for you. It doesn't increase your app size at all. And then it increases app performance. So less framework code is better for overall performance. This is especially a factor in app startup time, where JavaScript must be downloaded, parsed, and instantiated by the browser. I'm sure you're all very familiar with applications that you start up and you're just given a whole screen of loading things while everything goes and fetches its data before it can actually be active. And then lastly, it helps to reduce the app maintenance. So web APIs are unlikely to degrade over time. The web does a great job of making things backwards compatible. So the platform API that you depend upon today will be available in 10 to 15 years. And of course, browser vendors regularly ship critical security updates as well. No action is required by you or your users. You just take advantage of what the browser vendor is already providing you. And that means less shenanigans from the package managers that we all know and love. Now, while it is an improvement to have the browser native way to implement reusable components, they're still bound by JavaScript. That means if anything goes wrong with the JavaScript on your page, like a network error, something is blocked by the firewall, an ad blocker kind of throws up some issues, you have a browser plugin, or you work for the government and you have an obsolete browser, the web component may not even load. And the reason for that is this. Your web component is defined as a JavaScript class, and then it is not usable by the browser until that call to custom elements defined. So that's what tells the browser that my custom element, well, I need to use this JavaScript code in order to be able to instantiate it. Now, luckily, browsers are smart enough so that if this code doesn't run, it doesn't break your web page. You don't have an error. What happens is that the unknown tag is just treated as a span. So you may not get all of the behavior that you want to inside of your web component, but it doesn't break anything. But how do we go about ensuring that we always get a serviceable web page? And, it's this new technology. You've probably never heard of it before. It's called server-side rendering. Of course, I'm joking. I'm sure you've heard of server-side rendering. It's as old as the web. That's how we always used to do things. It's just, I was into it before it was cool because I'm old. You've heard that I've been doing this for over 20 years, right? And that's why we created Enhance. It's a server framework that enables you to expand web components on the server and deliver working HTML to your client. Then your components can upgrade themselves in the browser to provide interactivity via JavaScript. So you kind of get the best of both worlds. By combining web components, Enhance, the Node.js runtime, we're able to produce HTML. This leads to a number of benefits, including improved performance, as we offload part of the render task to the server, which gives your browser a lot less work to do. It gives you better SEO, as it's easier for web crawlers to parse the server rendered HTML instead of JavaScript-heavy pages. And finally, it's a better user experience, as we remove the need for loading spinners, so the user doesn't have to wait for JavaScript to execute and render at the content. Unfortunately, our solution is bound to the Node.js runtime, so we started thinking about how we could support other languages and runtimes. And that's where WebAssembly comes in. WebAssembly is a machine code language, and you don't actually have to write WebAssembly. I mean, you could, but that kind of leads to madness. Instead, you write your code in other languages of your choice and compile it into a binary format that provides near native performance. So WebAssembly is designed to run in the browser, but that doesn't mean it only runs in the browser. We can make use of it on the server, and that's what we'll be doing to take advantage of WebAssembly's performance to be able to run some server-side rendering. So now we combine our web components with a WebAssembly compiled version of Enhance and any runtime that you want, and we're producing working HTML. That's pretty good. And when I say any runtime, I really mean any runtime. If you don't see your favorite language or runtime on the slide, we just haven't gotten to it yet. But pull requests are always welcome. In fact, just yesterday, during our weekly Enhanced community call, a community member, Ben Patton, announced that he's added Elixir support. So if you're wondering how you can get involved like Ben, please join us. Enhance is 100% completely open source, and we would love for more folks to be able to collaborate with us on bringing server-side rendered web components to everyone. So we've built a number of examples, but we're not experts at every possible programming language or framework. We'd all love for you to bring your expertise to the project. Let us know where we got things wrong and help make things better for everyone. So if you're interested, please visit enhance.dev/WASM to get more information, or hit me up at that Mastodon account that I talked about earlier. So again, please join us at enhance.dev/WASM to get more information. And thanks, everyone.
Hey, Simon, thank you very much for that informative talk, sir. Really appreciate it.
Yeah, I'm glad you liked it. And, it's got darker here, but I'm not knocked offline yet.
I apologize. I was totally muted and heard not a single word you said.
That's okay. I was just noticing it was getting darker and darker as I was doing my talk, but I haven't been knocked offline yet, so that's pretty good. The demo gods were with us.
Sounds great. Thanks very much, Simon. You have a good day.
Thanks. You too.